For humans, the concept of a beginning and an end is a natural one. Birth and death are our parameters. We measure everything we do within this reference. Since the dawn of mankind's awakening, we have looked up at the night sky and wondered what it was all about. We have attributed the events in the sky and the existence of the stars to deities, monsters, and fables. Today we have a better understanding of our planet, the solar system, and our galaxy and beyond. But that understanding is still very limited. Think of the cosmos as infinite, and within this cosmos is our universe, one of many. The estimated age of our universe is 13.8 billion light years. This would make the diameter of our known universe a little less than 28 billion light years. However, since we are viewing the light from the very edge of the universe as it was 13.8 billion years ago, and the universe is still expanding, in fact the estimated acceleration is a factor of 3 times the speed of light times the time. It is now estimated that the diameter of the universe is approximately 93 billion light years. This is a vast distance. Light travels at 299,793 kilometers per second, or approximately 10 trillion kilometers per year. According to NASA's Spitzer Space Telescope, space is expanding at a rate of 74.3 plus or minus 2.1 kilometers per second per megaparsec. A megaparsec is approximately 3 billion light years. This is really fast and is getting faster. The current theory is that our universe started as a singularity, and after the Big Bang, at 10 to the power 10 minus 43 seconds, the universe was incredibly small, dense and hot. The area of the universe was 1 to the power 10 minus 33 centimeters. Today, this area of space spans billions of light years. Big Bang theorists believe during this phase that energy and matter were inseparable, and the 4 primary forces of the universe were also a united force. These 4 fundamental forces have been identified and have rather different properties. A strong force is a very strong force, but very short-ranged. It acts only over ranges of order 10 to the minus 13 centimeters and is responsible for holding the nuclei of atoms together. It is basically attractive, but can be effectively repulsive in some circumstances. The electromagnetic force causes electric and magnetic effects such as repulsion between like electrical charges or the interreaction of bar magnets. It is a long-ranged, but much weaker than the strong force. It can be attractive or repulsive and acts only between pieces of matter carrying electrical charge. The weak force is responsible for radioactive decay and neutrino interactions. It has a very short range and, as its name indicates, it is very weak. The gravitational force is weak, but very long-ranged. Furthermore, it is always attractive and acts between any 2 pieces of matter in the universe, since matter is its source. The 4 fundamental forces all play central roles in making the universe what it is today. But with respect to the large-scale issues that are of interest to cosmology, it is gravitation that is most important. So the cosmos is infinite, and our universe is within this cosmos. It is expanding, and the galaxies are flying away from each other. But within galaxies, there are strange anomalies called black holes. A black hole is defined as a region of space from which gravity prevents anything, including light, from escaping. The theory of general relativity, E equals mc squared, predicts that a sufficient compact mass will deform space-time to form a black hole. There are believed to be 3 types of black hole. The first type comes into existence when a star with at least 5 times the mass of our Sun collapses. The second type occurs when 2 neutron stars collide. And the third type are supermass black holes at the center of all galaxies, for which scientists still have no idea how they are formed. Some black holes are so massive, for example, NGC 4889, 6 billion to 37 billion solar masses, the size of our Sun. One of the smallest ones is Sagittarius A, 4.1 million times the mass of our Sun, and is at the center of the Milky Way. And it is the black holes that may hold the key to the formation of our universe, and also to a strange anomaly observed by the Hubble telescope some years ago. As black holes form, they suck in anything close by. The gravity is so great that not even light escapes from them. As they grow to massive sizes, they swallow up planets and suns and even smaller black holes. Should two black holes collide, they will create a super black hole, and this may well accelerate the rate at which the surrounding space is sucked in. There will come a point when a black hole is so dense and compact that it cannot suck up anymore, and it might be at that point that the energy stored within the black hole is so great that it explodes like a big bang, altering space-time in the immediate area, and as the time-space shock wave moves out into space, it will alter space-time there too. This could give rise, over millions of years, to a strange phenomenon recorded by the Hubble telescope, a young solar system next to an older one. One possible explanation is the explosion of a black hole results in a new solar system, and over millions of years it occupies space and time next to an older system. As black holes collide, continuing to suck in all that is around them, they will become ginormous and could possibly occupy so much space and time that they become so dense it has no option but to explode. A really big black hole would then in effect create a new universe, which could engulf the existing universe or create a totally new one, moving the existing universe out of the way. Would there be a defining line between the new and old universe? Would they naturally have the same chemical constituents? Would the physics be the same? Are other universes made up of the same building blocks as our universe is? This process would seem to be one that could occur over and over again. If so, the cosmos would be truly infinite. Our universe would be one that continually reinvents itself and could be one of many existing in the cosmos. Overlapping in space and time would seem plausible. Our universe is expanding, and black holes may well be the instrument by which the universe reinvents itself. An exploding black hole might well overtake the expanding universe. There's so much not understood and so much to discover. Multiple universes may be once more part of the solution.